past, present, and future. Well, there was release 1.24.0, which was a month and a week or two ago. This one, as usual, took quite some time, and this time we were waiting sort of for RP 2350 support to go in. But yeah, once it was all ready, it was, I think, quite a good release. There were lots of things. The headline being the RP 2350, the new chip support for that, as well as ESP32C6 support. So yeah, ESP32 has quite a lot of variants now, and there's, I guess, more to come. The RP2350 and the C6 both are RISC-V. Well, are RISC-V cores. The RP2350 has an option to be either an ARM or a RISC-V core. If you haven't looked at this chip, it's quite interesting. You can boot in one or to the other, as in ARM or RISC-V, and play around with RISC-V. So we had also in this release improved native emitter support for RISC-V. There's still a bit to finish off there, like inline assembler, which should come soon, and dynamic native modules for RISC-V. But the basic app MicroPython.native and app MicroPython.viper works. The other thing was, as it says, common tiny USB code. So tiny USB is becoming more tightly integrated into MicroPython and used for all the ports now except STM32, and it will be soon. And that's really good because that means they can all use the same code and the same dynamic USB driver that we have as well. So that was sort of the main things, but also another thing that's not in that headline there is the enhanced MP remote support, which is a good for recursive copy of MP files to a MicroPython attached board, and it can use hashing to see if the file needs to be copied or not, which can quite significantly speed up copying. So when you go to copy a whole big directory structure recursively, you can check each file's hash on the PC and on the board and see if it needs to be copied and skip it if it doesn't. And there are a few other improvements with MP remote along with that. There's also a more portable UART IRQ API. So the boards that have a UART, you can register IRQ for various events like receive or transmit. So thanks to Robert, who's on the call, for a lot of his help with that and implementing that. Zephyr, the Zephyr port has also matured a bit more and has support for threading. And along with that, there's also support for Bluetooth coming. That didn't make it for the release, but there's improved events support, event handling in the background. So that's maturing more, which is good because it will be useful for upcoming Nordic chips, I think. So these are the main things in 1.24. There was also some other, there's always lots of bug fixes, lots of improvements, things that happen behind the scenes, testing to make testing. Testing is obviously very important, and the better the tests are, the better the releases are, because things have less chance to break. And it's quite hard with, for example, the ESP chips, because there's so many of them, and the IDF changes quite quickly, and we try to keep up to date with recent IDF, that there are things that inevitably break when moving so quickly. So having good tests is important for that. So we're always fixing things like tests and docs in the background. Another thing which was added, thanks to Andrew, was MicroPython ring IO, which is a class used for ring buffer at the Python level. So it's Ring IO because it's like a stream, like a bytes or a string IO object. So you can read and write like a stream, but it's actually a ring buffer behind the scenes. So it's sufficient for queuing bytes and dequeuing them and passing them between threads or interrupts. So that's a pretty useful thing that's been added. Also, we've added a new networking configuration function. So the old one was called ifconfig, and the new one's called ipconfig. And the reason that we've done this, we don't really like to duplicate functionality like this, but in this case, we needed to support IPv6, and the old ifconfig method was not very flexible. It was just simply, set DHCP and get the IP address. Whereas with IPv6, there's a lot of extra things you want to configure. And so ipconfig should now be used instead of ifconfig, although ifconfig is still there. ipconfig is a lot more powerful and allows IPv6 support if that's enabled on your particular board, and it is on the PicoW. So
I was going to ask, which other boards is IPv6 available then, Damien?
Well, ESP32 should be able to have it, but we haven't enabled it. I'm not sure exactly how it works there with the IDF and whether it, well, I'm sure it supports it, but I'm not sure how to configure it exactly. STM32 and all the other ones, we should just be able to enable that as well because they're bare metal like RP2 port and PicoW, but we just haven't. The demand was there for the PicoW, and the person that contributed this wanted it on that board, so that's why it was enabled there. But I guess moving forward, we should enable it on more ports because it will be more useful if they can afford it from size. Some ESP32 boards are already pretty close, so we don't want to overflow them. But to answer your question, the PicoW is the only one that supports it out of the box. The other thing there, you can see network PPP. This also is not enabled unless you're doing it yourself, building firmware yourself. But there was quite a lot of interest with PPP support, and when we added it, then it seems that more and more people were interested in it, which is interesting. So that's there, and there was a lot of testing went into that, but it's still, yeah, PPP is quite tricky to get right. Configuring the modem to connect, and then once it's connected, it's easy to hand it over to PPP, but connecting the modem is quite tricky. At least I found in my testing. But this has been on the ESP32 port for a while, but now it works on the PicoW and any other bare metal port that uses LWIP as a network stack. So that's a lot of the things that we've had. If we have a look down here, there's a summary that I make for the releases to show the change in code size for each port. And I think this is a useful way to understand sort of the changes that have gone on in this release. So this is going from the previous release to this release, how much the port has changed. So most of them went up, some of them went up quite a lot, and then but ESP32 went down by a huge amount. And that's because we changed the IDF version, and the new IDF version that we're on now somehow has optimized things really well. I'm not sure what happened there, but on the IDF side, but going to version 5.2.2 decreased the ESP32 port by a lot. The the other increases like here is due to new TLS ciphers that have been enabled, and mostly the new ipconfig method, and the ring IO class and the UART IRQ support that I've mentioned. So this is a good way to sort of see, okay, these features did really impact the firmware, and these were the things that were big in this release. These ports at the top we try and keep unchanged. The changes here are due to fixes for buffer overflow fixes and related things in int.2 bytes. So even a small change or a fix that you might think, oh, just a buffer overflow can lead to, 116 bytes is not much, maybe, but it is on projects where every byte counts. So we really try hard to keep that down where we can. So that's summary of most of the release. There were lots of people who contributed, who are all listed here, and you can see the time zones that people contributed from, which I've summarized. So it's really quite a global project. There's lots of people around the world who contribute, and many thanks to everybody. So after this release came out, it was tested well, and then there were quite a lot of bug reports, and so we had a patch release, which was only 2 weeks ago. So that fixed a few things that were missed because of IPv6 support on RP2. Multicast stopped working, so that was a bug that was fixed. ESP PWM had a problem, and SD cards as well. It was a bit of an oversight there. So there was a few things. We do try and test everything, like I said, but for example, testing SD card on all versions of ESP32 is not something that's done. We have since added PWM tests to make sure that doesn't happen again. And multicast, I do have a test, but it's not part of the repository yet. Angus has made tests for access point mode and channels, so we are trying to make sure that if we find a bug, we write a test for it, and it hopefully doesn't happen again. So if 1.24.0 is already obsolete, please use 1.24.1. It fixes the bugs that are listed here. And the next release, 125.0, is I plan to get it out hopefully before the end of this year, this release date here. So you can track, if you go to this milestone 8, you can track exactly what's on this release. The headline item there that's been in progress for a long time is the ROM FS, so the ability to have frozen code attached to your firmware without rebuilding the firmware. So the idea is you have a file system that you freeze into a ROM file system, a read-only file system, and put it on the device, and then you can run code in place, run bytecode in place on the file system, and also memory map files on the file system. And if you have a big font, for example, you can memory map that and actually access the font data from the ROM file system without loading it into memory. There's a lot of things that will be enabled with this, and it's very close to being merged, and then that will be the main thing to get the release, to blocking the release, but once it's done, the release will follow very quickly. There's a whole bunch of other stuff here you can see. I'm not sure all of it will get in. One of them that hopefully will is Pico2W support, which is nearly there. The Pico2W is the RP2350 with a Wi-Fi Bluetooth chip. And then some other things here and there, which we'll try and get in before the end of the year. But that's tight, but I think having this plan here is a good way to keep on track. Just the other thing I'd like to mention, I've talked a lot about testing and working closely at the moment with Hans from Octoprobe to do hardware in the loop testing. So we hope, well, the plan is, and it's looking good, that we will have many boards automatically tested at the press of a button or at the run of a single command line. So this text infrastructure will, I have something here I can show you. This this is 2, 4, 6, 7 boards that can be tested at once in this infrastructure here. So you can plug this in. It has many USB ports on this side. Plug it all into a USB hub, and the idea is that everything's automated. The compiling of the firmware, the flashing of the firmware, and the running of the test suites on every board connected here. And then this is only 7, but we plan to have 20 to start with. So, 2 stacks of 10 of these. And then it may take an hour or two to run all the tests on those boards, but that is all automated and much better than doing it by hand. So there'll be, most of the ports will be represented by a few boards, and there'll be not only just standard MicroPython tests, but there'll be hardware tests like PWM that we have, wireless tests, Bluetooth tests. So it will hopefully be a very good framework, which we can keep adding more and more and more tests to make sure that things stay stable and robust. And this will help a lot making the releases come out quicker, because a lot of the the last it takes like a week, sometimes 2 weeks to go through a release and test everything and fix the things that are broken, and then test again, and then keep fixing and break and testing until it's ready to be released. So having automated testing that can happen more regularly will definitely help, not only speed up releases, but improve quality of releases. So this is something that's I've been wanting to do for a long time, and Hans with Octoprobe has come up with a good solution, and very, very keen to see. He's very keen to see that move forward. So that's all I have to say. Thank you. You have any questions?
Done silence here.
It's done silence. Everyone's.
Hi.
Brad's got his hand up. Go ahead, Brad.
I have a question. You mentioned in your proposed changes of being able to incorporate MPY files into ROM. Isn't that done already with freezing the code?
Yes, you're right. It is. This way, it's done without having to rebuild the firmware. So for the moment freezing, you're required to rebuild firmware.
Right.
But the idea here is.
Uh-oh. He froze.
Until he comes back, I guess, yeah, the idea here is that you could build your firmware and deploy that. And then as a subsequent step, you could build your own file system, read-only file system, and deploy that as well.
Oh, that's very handy.
Yeah. So if you. No, even if you're already building firmware, this is a much faster way to freeze code in. And also, as I said, you can memory map files, which is another benefit.
Yeah, I see that being especially useful for some of these like the SP32 S3 with the large amounts of serial RAM that's available now, 8 megabytes. It's be nice, even though it's RAM, it'd be nice to utilize that as well, because that way you can change it. You could map it in, but it would be like a loadable module that would be mapped into the as part of the run in place, right? Would it be equivalent?
Yeah, you could definitely put a ROMFS in a RAM. That's totally doable. The tests do that already. So yes, that's possible. You can put it wherever it's mappable memory. Yeah.
Thanks, Damien. Yeah, I'm glad to hear it. So for people who didn't know too, Hans came over from Switzerland. So he came over for PyCon AU, flew over here, and then was out here for about a month, and has been working with Damien for every other day or something for the last week or two, working on this hill testing. So yeah, it's pretty cool to see that progress.